Hi, my name is Nur Najla Najwa Dasima binti Doris, DF220173, and I will talk about lab shear force in a beam. The objective of this lab report is to examine how shear force varies with an increasing point load and to examine how shear force varies at the cut position of the beam for various leading conditions. This is our data analysis. As you can see, conclusion for part 1 is load equal to mass multiplied to gravity, and shear force at cut is RB equal to force multiplied by A divided by length. For part 2, we calculate RB and RA and find the moment and vertical force at Y. Discussion. For part 1, the value of shear force increasing when the load that has been placed increase. The slope of the shear force also increased due to the increased load. For part 2, the experiment demonstrates that the shear force at the cut section accurately mirrors the combined force exerted from both sides of the beam, showing an equilibrium with the applied load.
Hi, my name is Nunadia binti Ahmad Razif. My number matrix is DF220114, and I will explain about span deflection. Deflection is a bending or sag caused by loading. A lovable deflection is generally expressed as a fraction of the span in inches. All structure member will deflect or flex under load. The amount of flex depends on the magnitude of the load applied, span of the member, and stiffness of the member. For the first one of objective is to determine the relationship between span and deflection, and second one to obtain equation with which we can determine the accurate value in beam deflection in many practical cases. So here's some result and calculation of how to get Young modulus, second moment of area, Y max, and percentage difference of each experiment with different length of span. For discussion, the finding indicates variation between theoretical and experimental result across 3 trials with different lengths. The percentage difference fluctuates, revealing the shorter span yield lower deflection value when the load is at the mid-span. Conversely, longer span result in higher deflection compared to shorter span in both theoretical prediction and experimental observation.
Assalamualaikum and hi, my name is Noreli Shafariha binti Muhammad Nur Hisham and my matrix number is 22074. So now I will talk about cantilever truss. Cantilever truss is just like the determinate cantilever truss above. The only difference in the inclusion of redundant member in the truss. The addition of the redundant member makes the truss indeterminate, and as the result of the truss need to be analysed differently. Next, the objective of this lab is to examine the statically determinate frame and to analyse the frame using the simple joint theory. For analysis data, strain reading and frame deflection can be determined by observing the result when we put load on the truss. After getting the strain reading, we can find the true strain by divided the load of fracture and the cross-sectional area at the fracture. Next, we have to determine the experimental force by using the true strain that had been calculated just now by using Euler formula. Last but not least, we have to calculate the theoretical force by using method of joint. Lastly is discussion. Based on the experimental result just now, the highest force that has been obtained is member 4, which is slightly different from theoretical result. Other than that, the theoretical result for both member 7 and 8 should be same, but experimental result is a bit different, which is lower than theoretical member 7 and member 8. Next, for member 1, member 2 and member 3, the theoretical result is negative 250 Newton. It is a bit different from the experimental result. This difference of the result that occur is due to several error factors when we handling the equipment.
Hi, my name is Muhammad Hazib bin Nozilan. So for mechanic of material lab number 4, we will be determining buckling of compression member and critical buckling load of aluminium stud. The definition in this buckling of compression is to apply the analyzation of critical load. It's defined by a structural part that is under a lot of compressive stress, suddenly failing laterally, where the ultimate compressive stress that the material can withstand in less than the compressive stress at the point of failure. The objective of this experiment is to examine how shear force varies with an increasing point load examined, and to examine how shear force varies at the cut position of the beam for various loading conditions. The critical buckling load will be represented by aluminium strut in this experiment. There are three different and restrained conditions that will be using, which is pin and fix, and fix and fix, and also three different strut length, which is 320 mm, 370 mm, and 420 mm. From the given result, it was found that is the pin and fix, and fix experiments, a shorter strut can withstand higher pressure compared to a longer strut. Additionally, the pressure capacity measured in kilonewton was highest for the fix and fix experiment using a 320 mm strut, that is reaching 106 kilonewton compared to other strut lengths. For discussion, I can summarize that show the fix and fix support is stronger than pin and fix and pin attributed to its rigid support. The terms represent distant buckling load, with fix and fix displaying superior absorption for earth load, indicating greater durability. A graph represents illustrate relationship between strut length and buckling load in both experimental and theoretical scenario. Fix and fix support show the highest value, while pin and pin support show the lowest value between buckling load and strut length.
Assalamualaikum and hi, my name is Tazwani binti Samsul Bahri with number matrix DF220183. I will explain overall about bending moment in a beam report. So basically, bending moment are defined as a structural component that created by transverse load applied to the beam. So the bending moment is equal to the area under the shear force diagram up to that point along the beam. The bending moment at the end of a simply supported beam is always equal to 0. The objective of this test is firstly to examine how bending moment varies with an increasing point load. Second, to examine how bending moment varies at the cut position of the beam for various loading conditions. So, all these elements must be reached to make sure the test is conducted successfully. All the data that have been obtained will be seen here. So, we can divide the calculation into two parts based on the requirements needed. So, for the part 1, we need to decide how much mass or load we wanted. After analysis done, the force value will come up. For the experiment bending moment and theoretical bending moment, the value can be get by using the formula shows. So, for part 2, W1 and W2 can be decided by observer. So, when analysis have been run, the force value will pop up. So, experimental bending moment, RA, RB, and theoretical bending moment, and all of these need to be calculated manually by the formula shows. So, all of the elements have been calculated and shows as the follow. From the graph obtained, clearly we can see that the graph for experimental bending moment versus loading has a linear line, but the theoretical bending moment has slightly different in a shape, like decrease at 0.98 Newton, but still increases until the end of the experimental. So, from
From this test, we can conclude that when load increase, so bending moment also increase. So for conclusion, the experiment is successfully since the experimental and calculation result within an acceptable range and the objective have been achieved.